The first time we heard Saturn, it didn't sound like silence. It sounded like a warning. In 2017, Cassini sent its last signal and then vanished into Saturn's atmosphere. Not because it failed, because we chose the ending. Saturn is not just a beautiful planet. It is a machine that breaks things. Out there, the sunlight looks clean, cold, almost holy. And then the instruments catch it. Invisible waves, charged particles, a magnetic engine dragging space itself into tension. When you translate those signals into audio, Saturn becomes a thin, rising scream like metal flexing under pressure. One day the rings won't be there. That's the part we keep getting wrong. We treat Saturn like a museum piece, a perfect planet wearing a perfect crown. But Cassini came back with a different story, one that makes the rings feel less like jewelry and more like evidence. Because something around Saturn is shedding material, something is losing mass, and the planet is quietly collecting the fallout. So here's the question that won't let go. What did Cassini discover that turns Saturn's beauty into a crime scene? The answer isn't in the pretty pictures. It's in the noise, in the invisible rain, in what's already falling. From a distance, the rings look solid. They aren't. They stretch nearly 300,000 kilometers across wide enough to span almost the distance from Earth to the Moon. But in many places, they're only about 10 meters thick, thinner than a 2-story house. That's not a structure. That's a sheet of debris. Saturn's rings are not jewelry. They are billions of pieces of ice and rock, each fragment ranging from dust grains to house-sized boulders, orbiting at tens of thousands of miles per hour, constantly colliding, shattering, and reforming in a silent ballet of impacts that never truly stops. Up close, there is no smooth halo. There is chaos, ice grinding against ice, particles spreading, clumping, spreading again. What we expected, frozen perfection. What we found, a demolition field in slow motion. Cassini proved it when it slipped between the rings and Saturn itself in 2017, diving through a gap only about 2,000 kilometers wide, narrow on a planetary scale and measuring the mass, the density, the pull of gravity on every pass. It felt the rings, and they felt light, lighter than they should be if they were ancient. If they're this thin, they shouldn't last. So why are they still here? And more importantly, what was torn apart to make them? Then you reach the North Pole, and Saturn stops pretending to be random. There, carved into the clouds, is a hexagon, 6 straight edges, locked in place. Storms aren't supposed to do that. The structure is wider than Earth. A hurricane system so vast our entire planet could sit inside it and never touch the sides. And it has persisted for decades, first seen by Voyager in the 1980s, then studied in detail by Cassini as it watched the shape hold, season after season. Storms don't draw straight lines. Yet this one does. At the center spins a vortex, dark and deep, with winds screaming around the edges at hundreds of miles per hour, sculpting geometry out of turbulence, as if Saturn's atmosphere briefly forgot how to be chaotic and chose precision instead. What we expected, swirling gas, messy and unstable. What we found, symmetry, persistence, a scar shaped like logic. Scientists think it forms from jet streams wrapping around the pole, locking into a standing wave pattern. Simple physics, but on a scale that feels engineered. Cassini circled above it, mapping temperature gradients and wind speeds, confirming it wasn't a trick of light. The hexagon goes deep, far deeper than a surface cloud pattern should, which raises a harder question. If Saturn can hold a storm in perfect geometry for decades, what else is it holding together under that atmosphere? Saturn doesn't rage every day. It waits. Roughly every 29 to 30 years, about one Saturn year, the calm bands rupture. A storm ignites. Bright, expanding, violent. They call it the Great White Spot. The last major eruption began in 2010. Cassini watched it bloom from a single bright plume into a planet-wrapping disturbance. Lightning flashing inside ammonia clouds, winds accelerating, heat rising from deeper layers, like a pressure valve finally giving way. It waits, then detonates. On Earth, hurricanes burn out in days or weeks. On Saturn, these events can encircle the planet, injecting energy into the atmosphere for months, leaving scars in temperature and chemistry that linger long after the clouds fade. A Saturn year is about 29 Earth years. That means one of these storms erupts roughly once per human generation. You are likely alive during one. What we expected: slow, sleepy weather on a distant gas giant. What we found: a system that stores tension for decades, then releases it in a single, blinding outburst. Cassini measured the aftermath: temperature spikes, disrupted jet streams, altered cloud structures, proof that Saturn's atmosphere isn't static. It breathes, it builds, it snaps, and if the surface can accumulate that much energy before breaking, what does that say about the forces shaping everything above it, including the rings? Here's the twist no one expected. The rings might be young. Saturn is about 4.5 billion years old as the solar system itself. But Cassini's gravity measurements during its final dives suggested the rings may hold less mass than we assumed. Less mass means less time. Some estimates place their age at around 100 million years. That's not ancient. That's recent. Dinosaurs ruled Earth longer than that. They might not be ancient. The brightness of the ice matters. Over billions of years, micrometeorites should have darkened the rings, staining them with dust until they turned grey and dull. Instead, they are still shockingly bright, as if whatever shattered to create them didn't break that long ago. This is still debated, not settled, but the possibility changes everything. What we expected: a timeless crown. What we found: a temporary aftermath. If the rings are only around 100 million years old, an estimate, not a certainty, then we are living in a rare window, a brief cosmic era, when Saturn happens to be wearing its most dramatic feature, like arriving just after an explosion and mistaking the debris for decoration. We arrived during the fireworks, and if they're that young, something had to die to make them. Then there's Titan. At first glance, it feels almost gentle, a thick orange haze, soft light scattering through hydrocarbons. Titan is not just a moon. It is a world running chemistry experiments in the dark. Its surface pressure is about 1.5 times Earth's, denser air than we breathe. But the temperature sits near minus 179 degrees Celsius, cold enough to make steel brittle. It rains gasoline, not water, methane, ethane. Liquid hydrocarbons fall from the sky, carve river channels, fill lakes the size of seas, and cycle through clouds in a weather system that looks disturbingly familiar, except everything is flipped into cryogenic slow motion. In 2005, the Huygens probe descended through that haze. It landed softly on frozen ground. Rounded pebbles lay scattered below, shaped by flowing liquid, proof that rain really falls there. What we expected: a frozen rock. What we found: an alien mirror of Earth. But Titan orbits Saturn. It lives inside that gravitational system. Tidal forces flex its interior. Radiation brushes its upper atmosphere. And if Saturn's rings are debris from something that broke apart, Titan is close enough to wonder whether moons are safe here at all. Because Titan isn't the only one leaking secrets into space. Enceladus shouldn't matter. It's small, only about 500 kilometers across roughly the width of Arizona. Bright, icy, quiet. Until it wasn't. Cassini flew past it and saw jets erupting from fractures near its south pole. Plumes of water vapor and ice blasting hundreds of kilometers into space. A moon spraying its ocean into the vacuum. It was alive with chemistry. Cassini flew through those plumes. It tasted them. Instruments detected water, salts, and organic molecules, carbon-based compounds, the raw ingredients life uses on Earth. Salt means contact with rock. Rock plus water means energy. Energy plus organics means possibility. What we expected: a frozen snowball. What we found: a leaking ocean. That discovery changed everything. Because if there is even a slim chance of life in that ocean, then contamination becomes unforgivable. Cassini had been orbiting Saturn since 2004. Fuel was running low. Its orbit was becoming unstable. Physics does not forgive. Left uncontrolled, it could eventually crash into Enceladus or Titan. And if it carried even a microbe from Earth, it could corrupt a world that might already be experimenting with biology in the dark. So, the decision was made. Cassini would not be allowed to fall randomly. It would choose its ending. In September 2017, Cassini turned its antenna toward Earth one last time. Signal locked. Data streaming. Then it fell. Not by accident, by design. Engineers commanded it into Saturn's atmosphere to avoid contaminating Enceladus or Titan worlds that might host chemistry too precious to risk with a stray terrestrial microbe. It died on purpose. As it descended, the atmosphere thickened. Friction built. Thrusters fired to keep the antenna pointed home. Every second mattered. Even as the plasma tore at it, Cassini held its orientation, transmitting measurements of atmospheric composition and gravity until the final carrier wave dissolved into static 1.4 billion kilometers away so far that the signal took over an hour to reach us. And in those final orbits, Cassini confirmed something unsettling. Saturn's rings are raining down. Charged water particles spiral along magnetic field lines and fall into the planet's upper atmosphere. Ring rain. Material returning home. At the measured rate, scientists estimate the rings could fade within about 100 million years. An estimate, but plausible. In cosmic time, that's a blink shorter than many species survive on Earth. We live in Saturn's brief shining era. Every beautiful system is temporary because gravity always redistributes matter. Planets form, moons break, rings disperse. Studying Saturn refines our models of atmospheres, magnetic shielding, and planetary evolution, the same physics protecting Earth right now. Saturn shines because something broke, and the evidence is already falling.